Hi everybody, I'm Dinesh Joshi and I'm a committer and PMC member with Apache Cassandra. I have been working in the distributed systems space for over a decade building large-scale distributed systems, and today I will be talking to you all about Cassandra 4.0. 4.0 is the next major release of the open source distributed database Apache Cassandra. It brings several major changes to Cassandra, and it is one of the first releases of Cassandra that has been driven by some of its largest users. The features and improvements that Cassandra 4.0 brings to the table are not specific to Cassandra, but can also be applied to other distributed systems. And through this talk, hopefully you will learn some of those features and improvements that are key to Cassandra 4.0's success. Today, I will be going over the background of the problem space we are all in, followed by a brief architectural history of Cassandra, and then cover some key improvements in Cassandra 4.0. This is by no means an exhaustive list of features that Cassandra 4.0 has to offer, but only a choice few that I thought were interesting. These improvements are in areas such as performance, efficiency, stability, operability, and observability. In closing, I will summarize the improvements that Cassandra 4.0 has over the prior releases. I assume we are all familiar with graphs like these. This shows the industry data growth trend, and this has been going on for a while now. That we have seen a hockey stick jump of the data that users have been consuming or producing, and our industry is very reliant on data that is produced out there. And in the past, we could tolerate downtime. We could tolerate data being unavailable for a little while, but in today's world this has become far more critical. So we can't just be offline. We need high availability. One of the driving factors for this growth in data is because of various applications such as IoT devices and general growth of the data intensive applications in the industry. And as a result, all the systems in our distributed system space have to cope up with this growth of data over the period of time that we've seen. The data growth needs to be handled gracefully by systems such as Apache Cassandra. And in order to keep up with this data growth, Cassandra also has to change with times. Cassandra is widely deployed in the industry. There are various versions of Cassandra that our community supports. The 2.x series is the most widely deployed and is stable. The 3.0 series is stable and is adopted fairly well in the community, while the 3.11 series has some performance improvements, but it's not widely adopted yet. 4.0 is the next major release of Cassandra we are talking about today. Coming to Cassandra's architecture, Cassandra was built to be run on top of cheap commodity hardware. It is a quorum-based distributed database with tunable consistency. It aims to achieve high availability and is horizontally scalable. It has various components to it. Each Cassandra instance is called a node. It owns a range of data called token range and is able to maintain high availability through replicating its data to its replicas. When Cassandra receives a read or write request, it will try and reach a quorum of replicas. This means that a majority of replicas need to acknowledge that read or write in order for it to succeed. We generally have 3 replicas, and this means the database can continue accepting reads or writes even when one of the 3 replicas is unavailable. The database continues to operate as long as a majority of the replicas can be reached and are in agreement on the view of the data. This architecture is very reliable, but it has its limits. As we add more nodes to the Cassandra cluster, we see almost linear scalability for its throughput. Up to a certain point, though, after which the throughput basically levels off, and in some situations, it can even fall off the charts, which means that we can't grow infinitely even if we keep adding hardware to the database. So this is an important bottleneck for us to address with the growing trends in the industry. With Cassandra 4.0, we bring in a huge number of changes. We have over 300 bug fixes, features, enhancements, and have gone through that have gone into the database. These have been contributed by several key industry players that use Cassandra at scale. The number and complexity of changes is truly mind-boggling. Let's look at some of these changes in Cassandra 4.0. At first, I'd like to talk about repair. Repair is basically a process within Cassandra that allows us to converge data. Since Cassandra is a quorum-based system, nodes can go offline and at any point in time. As long as majority of the nodes are up, the data that Cassandra is serving or reading or writing is available to the user. So in some situations, the data can go out of sync, and repair is a process that brings that data back into its consistent state. So as Cassandra is basically a eventually consistent database, we can only make sure that the data is consistent by running this background process, and sometimes repair can also run in foreground. But this is a slow process. Cassandra has a feature called Incremental Repair. This feature shortens the data reconciliation times dramatically. Pre 4.0, this feature did not work reliably at scale. And with 4.0, not only does this feature works well, but brings down the total time that is taken to repair data to minutes. This is a phenomenal improvement compared to a full repair, which can take hours, days, or even weeks depending on the size of the data. Incremental repair is a phenomenal improvement that Cassandra brings to the table. Transient replication is another interesting feature that 4.0 brings. This is an introduction of witness replicas to improve Cassandra storage efficiency. Let's see how it works. So, plain on Cassandra replication creates full replicas of your data. In this case, when we have replication factor of 3, you have replica 1, replica 2, and replica 3. All three nodes are full replicas, which means that the data that is being stored is a full copy of the data. So if you had 100 gigabyte of data, it is now replicated thrice into 300 gigabytes. And that's an added cost. With transient replication, we can actually reduce this cost. And for example, with transient replication with the same replication factor, you have replica 1 and replica 2, which are full replicas, while replica 3 is essentially a transient replica, which is only going to store the unrepaired data, while R1 and R2 are going to store the fully repaired data. And as soon as both of them are in sync, replica 3 basically drops all its data, thereby saving storage space. So the impact of transient replication is essentially it promises better space efficiency without losing any durability guarantees. We predict a reduction of up to 33% in storage space for RF equal to 3 while maintaining the same durability guarantees as before. A major area that Cassandra improves on is the internode messaging. Internode messaging is the internal messaging layer in Cassandra that allows nodes to communicate with each other. This used to be a major scalability bottleneck for large clusters. Cassandra 4.0 completely revamps it to use async I/O. This dramatically reduces the thread count that Cassandra uses and has improved latencies and memory efficiency. We have also improved the internode encryption performance and garbage collection characteristics by using NetEase TLS implementation. This bypasses Java's SSL and instead uses JNI bindings to OpenSSL. Overall, we have seen a dramatic reduction in the latencies as well as an increase in the throughput of Cassandra as compared to 3.0. One of the biggest bottlenecks in Cassandra was replication. Replication is the process with which Cassandra is going to copy its data from one node to another node. And the current replication is slow and it's CPU bound. Whereas with the 4.0, replication has been modified to use zero copy, and we call it zero copy streaming. With zero copy streaming, it speeds up all streaming operations within Cassandra. So if Cassandra is streaming data from one node to another node, operations are about 5 times faster. The operations are now IO bound, which means it depends on the speed of your disk and the speed of your network interface card. With these changes, Cassandra can replicate its data without really involving the CPU. It only depends on your network. And as a consequence, it has a dramatic improvement in the mean time to repair, which is essentially the time it takes for you to repair a down node and replace it with a fresh node. And this is overall reducing your operational cost as well as reducing your risk associated with down nodes, because the nodes, as we saw earlier, the longer the nodes are down, the harder it gets for you to maintain the consistency of data amongst all the nodes. And so tolerating a down node for a little while is better than tolerating a down node for several days or weeks, even in case you're not able to recover the nodes very quickly. This graph shows the time to recover a failed node in Cassandra 4.0 as opposed to Cassandra 3.0. The green line is the 3.x series Cassandra instances, while the blue line is the 4.0 dev branch. Recovering a node is not just replicating data, but also involves some internal bookkeeping and building data structures. This shows the impact on a real world metric that the operators care about. More info on the Jira ticket that is linked below. We have several bug fixes, but one theme that Cassandra 4.0 adds is checksumming everywhere. We had checksumming in the database, but missed it in a few areas. 4.0 corrects this. We now have checksumming on our native protocol, internode protocol, and SS-table metadata, essentially everywhere. The next feature I want to talk to you about is audit logging. Audit logging is a feature that allows Cassandra to log pretty much everything. If you have to work towards industry compliance, such as SOX, you are in luck. With 4.0, we bring performance logging to the table. It helps in compliance for enterprises and anybody who's looking to log for auditing purposes. An area that operators and SREs care about is observability. This is critical for any systems. Until Cassandra 4.0, we used to use JMX, Java Management Extensions, to expose a host of metrics, tunables, and miscellaneous information. JMX brings a host of issues, including security issues. In 4.0, we introduced virtual tables. This is a feature that allows you to export metrics and other data through the same interface that the client uses to query the server. These look like real database tables, but they are only in memory and backed by an API. Here's an example of a virtual table. This virtual table is queried like any other Cassandra table. It exports memtable metrics that you would otherwise need to explore via JMX. Here's another example showing settings that Cassandra has loaded in memory. A critical feature on the security side is SSL Certificate Hot Reloading. In today's world, we actually are seeing a lot of adoption of better security practices across the industry. And one of the things that people like to do is rotate their certificates more frequently. And whenever you rotate a certificates, we have to bounce instances, restart instances in order to pick up the newer SSL certificates. And Cassandra brings hot reloading of those SSL certificates. What it essentially means is that the operator can just update the certificates on disk, and Cassandra can pick it up whenever it checks the presence of a new certificate, and it loads that certificate in memory. And there is no disruption to live traffic. The user can just continue using Cassandra without any interruption. And it basically reduces the burden on operators who have to keep bouncing instances whenever a new SSL certificate is issued to that Cassandra instance. And this enables us to use short-lived SSL certificates, so that they expire way more quickly than usual certificates which have longer expiry, thereby improving the security posture of your database. Cassandra 4.0 introduces another interesting algorithm called Zstd. This is a compression algorithm that allows us to save some additional disk space. It has distinct advantages over LZ4 and can save up to 40% disk space depending on the configuration that you use, while keeping comparable performance. It has checksum frames for data integrity, and Cassandra uses JNI bindings to bring in additional performance and lowers the GC overhead. Here we see a graph that shows performance of zlib versus zstandard. The green line is zlib and the blue line is zstandard. Zstandard is able to achieve better throughput while maintaining or improving the compression ratio. It can also achieve better compression ratios than zlib. It gives the user the ability to choose from a wider range of settings compared to zlib. Here's the graph that compares zstandard with zlib and LZMA. These are the two most popular libraries that are used out there. Zstandard wins out by a fair margin in terms of decompression performance. In practice, Zstandard's compression performance is slower, and therefore Cassandra adopts a tiered storage strategy where memtables are flushed using the fastest available compression algorithm, while compaction recompresses the data using Zstandard. That way we don't block writes and still end up saving space. Finally, Cassandra brings full query logging to the table. This allows us to capture queries on one or more Cassandra nodes and replay them. This is critical in building test infrastructure where you need to capture and replay production traffic using a tool. We also have a tool to compare the output of the captured logs in order to determine the differences, if any, in the query output. It is, as I mentioned earlier, very useful for replaying traffic. So, in summary, I want to say Cassandra 4.0 brings better operability, scalability, latencies, and faster recovery times to the table. It has been one of the most significant releases that Cassandra community has worked hard towards building, and it's the first release where the features have been driven by some of the most prolific users of the database. And that's all I had for today. Thank you for attending my talk. There's plenty more to learn. Please connect with the Cassandra community at cassandra.apache.org to learn more about the new features in Cassandra 4.0. Thank you.